In this module, I am going to discuss about the concept nuclear chemistry in the form of MCQs. Question number 1. The combination of deuterium and tritium gives a stable nucleus of helium and energy equal to 17.6 milli-electron volt is liberated. Find which type of reaction it is. Option 1, nuclear fission. Option 2, nuclear fusion. 3, artificial radioactivity. And fourth option is radioactive disintegration. Nuclear fusion refers a reaction which happens when two light atomic nuclei combine and form a single heavier one, releasing a massive amount of energy. The combination of deuterium and tritium gives a stable nucleus of helium is a nuclear fusion reaction. In this fusion reaction, the deuterium and tritium are heated to extremely high temperature where they overcome their natural repulsion for each other. They combine or fuse together, forming a heavier nucleus. This heavier nucleus is a helium atom. Helium is formed with 2 protons and 2 neutrons in the nucleus. One additional neutron gets emitted in this reaction because tritium, the heaviest hydrogen isotope with 2 neutrons, and contributes 1 extra neutron that is not needed in the helium atom. The resulting helium atom is less massive than the 2 hydrogen isotopes that came together to create it. Hence, the correct option 2, nuclear fusion. Question number 2. Stable nuclides for lighter elements are those whose N by P ratio is option 1, N by P ratio is equal to 1. Option 2, N by P ratio is greater than 1. Option 3, N by P ratio is equal to 2. Option 4, N by P ratio is less than 1. For very light nuclei like hydrogen, helium, the ratio of neutrons to proton for stable isotopes is approximately 1. This is because these lighter elements do not require as many neutrons to overcome the repulsive forces between the protons in their nucleus. But it is also important to note that as we move to heavier elements, the N by P ratio starts to increase above 1 in order to maintain stability due to the stronger repulsive forces between a larger number of protons. Hence, the correct answer option 1, N by P ratio is equal to 1. Question number 3. Which of the following is used for the production of nuclear energy? Option 1, coal. Option 2, petroleum. Option 3, sodium. And option 4 is uranium. Uranium is a heavy metal that can be used as an abundant source of concentrated energy. Uranium occurs in most rocks in concentration of 2 to 4 parts per million, and it is common in the earth crust as tin, tungsten and molybdenum. When a neutron strikes the nucleus of an atom of uranium-235, the nucleus splits and releases energy in the form of heat. This heat is used to generate steam that drive turbines to create electricity. Uranium is an abundant metal and able to release abundant concentrated energy. Hence the correct answer option 4 uranium. Question number 4. Alpha particle is charged. Option 1 negative charged particle. Option 2 positively charged particle. Option 3 neutral particle. And fourth option massless positively charged particle. Alpha particle is composed of 2 protons and 2 neutrons bonded together. This structure is essentially equivalent to the nucleus of a helium atom. Neutrons are neutral, so they do not contribute to the overall charge of the alpha particle, but they do contribute to its mass. Therefore, the alpha particle is definitely not massless. Alpha particles are thus neither negatively charged nor neutral. They carry a positive charge due to the protons in their structure. Alpha particles are emitted during alpha decay, a type of radioactive decay. It is one way unstable atomic nuclei can release energy to become more stable. So the correct answer option 2 positively charged particle. Question number 5. Complete the equation for the following fission process. If fission process is given, 4 options also given. We know that fission produces 3 neutrons per reaction. So one of the products will be 3 neutrons. After and before the reaction, the sum of the atomic number on both sides will be the same. The sum of the atomic number before the reaction is 92, which is equal to the sum of the atomic numbers after the reaction. The sum of the atomic number of the product is equal to 36 plus X, where X is the atomic number of the unknown element. The net equation is 36 plus X is equal to 92, where X is equal to 56. Hence, the element produced is of atomic number 56, which is barium. The ultimate product are thus barium 56-141 and 3 neutrons. Hence, option 1 is correct.